Hello everybody, this is Unit 5, Day 5. We're looking at mixed sequences here, okay? So the important part about this lesson is to take away that sometimes they don't tell you what sequence you're looking at, right? Whether it's arithmetic or geometric. So it's going to be up to your intuition to figure that out, right? And hopefully at this point I've given you the correct amount of tools in order to be able to decipher whether they're arithmetic or geometric, okay? So in this first one, it looks like we're adding by 3 each time. Let me zoom in here. Looks like we're adding 3, adding 3, adding 3. So our common difference is 3. Our first term is negative 12, and so our equation, our nth term, is a sub 1 plus our common difference times n minus 1. All right, and so this becomes negative 12 plus 3 times n minus 1. Okay, now maybe you used your calculator, okay, and if you used your calculator, you would have had to have put in L1, first term, second term, whatever term you're talking about. L2 would be whatever those term numbers are. And then stat, calc, linear, reg. Okay? And that will also give you the formula for finding the nth term. And then you can use that one as well. Okay, so a couple different options there. It wasn't specific on how they want you to write the formula, so you can use your calculator or you can utilize the formula from the reference sheet. Okay, so the next one. All right, looks like we are multiplying by 3 each time. Okay, it's important to point out that when your terms So let me write this down. When your terms are negative, or when your R value is negative, okay? Therefore, we cannot use calc for regression, okay? And that's only for exponential regression, okay? All right, so in this particular problem here, if you went to try to plug these into your calculator using, your first term, second term, right, L1, L2, first term, second term, negative 2, negative 6, okay, you would end up getting an error. Okay, so your calculator's got its limitations, and one of those limitations is that it does not like calculating exponential regression involving negative numbers. Okay, so if you wanted to, I guess you could adjust them to make them positive and just recognize that you would have to put that negative back in there. But that sounds like a nightmare. Hold on a second, Mike. Give me a second. My mask was tangled in my headset there. So anyway, if that's something you would like to try, right, maybe utilize your calculator and then just making sure that you recognize your first term is negative, the easiest way would just be to use the formula from your from your reference sheet, which looks like this. Okay, so our first term looks like is negative 2. Looks like we're multiplying by 3 each time, n minus 1. All right, and this one we cannot use our calculator for. Okay, let's take a look at number 3. Number 3 and 4, okay, are very similar, except, one's arithmetic and one's geometric. Now remember, arithmetic sequences are linear in nature, which means these sequences are increasing or decreasing by a constant amount, kind of like our slope, right? Our common difference, or our d-value, is almost like the slope from a linear equation. Not almost, it is, right? And so, knowing that piece of information and knowing that we only have our 4th term and our 12th term, and retrospectively we need this formula, right? Because the question's asking us for our 24th term, right? And we don't even have our d value. We don't have our 1st term. We don't have any of that stuff. So what we can do is this, right? We can treat these as if they were actual points on the graph here, right? Which they technically could be, right? And so I'm going to treat this as x1, y1, x2, y2, okay? And because they're linear in nature, and because we're missing that common difference, right? What I'm going to do is I'm going to find the slope between these 2 points on our graph, and that slope will be our common difference, or what we're increasing. In this case, looks like we're decreasing, right? Our slope should be negative because our 4th term is 80, our 12th term is 32. So we're actually going down. Okay? So when you plug this in, you get 32 minus 80 over 12 minus 4, which gives me negative 48 over 8, which gives me negative 6. And so that knowing negative 6 is our d value, right? If this is 80, which means we're going down by 6, down by 6, down by 6 to get back to our 3rd, 2nd, and 1st term. We're going to add 6, right? So this one's going to be 86. This one's going to be 92. And this one's going to be 98. All right, so there's our 1st term, our d value. So we got everything we need. We shrink this down here. We don't need that so large. All right, so this is going to be a sub n is equal to our 1st term, 98, plus our d value. So I'm going to turn that to a minus 6 and minus 1. And we're looking for our 24th term. So you can either plug this guy into your calculator, right, using your y equals. You can turn this into, well, in this case, we already know those values, right? A1 would be 98 minus 6 raised to the x minus 1. You can put that into your calculator. We'll give you your 24th term, right, by looking at your table of values. Or we could simply just substitute this in for n. So 24 minus 1. So 98 minus 6 times 23. I do not know what that is off the top of my head. So 6 times 23. Negative 138. 98 minus 138. Go to negative 40. So our 24th term is negative 40. Okay? And that's for the arithmetic. Now, if you look down into number 4, right, now we could technically use our calculator for this as well. Okay, remember there's no wrong way to eat a Reese's, right? We could have plugged these into our L1 and our L2 and then found the equation that way. And then found our 24th term. Okay? Or you can do it the grunt way, right, like I did there algebraically, using the slope formula and then finding the rest of our pieces. Okay, so up to you guys, up to you. Couple ways you can solve this, right? Use your calculator, or you can do it algebraically, right? So make sure you're comfortable doing both, right? Because you never know which way they're going to ask the questions here. And if you look at number 4, as you can see, right, they're giving us those 2 points, but because these guys are negative, we cannot use our calculator for this method. Okay, so we actually have to do number 4 algebraically. Okay, so how do we go about doing that? Well, these aren't linear in nature, so we can't just do what we did last problem and just find our average rate of change. Because in retrospect, there is no average rate of change for this one. Okay? And so, we'll have to solve it another way. So let's think about it like this. Okay? Now, because we can't use our calculator, right, because these are negative, okay, we're going to just plug these in where they go, right? Our second term is -6, and our fifth term is -1296. Okay, so it looks like it's getting smaller. Now, they tell us it's geometric, which lets us know that we're multiplying by a common ratio each time. So to get from our second term to our third term, we're going to multiply by r. Third to our fourth term, multiply by r. Fourth to our fifth term, multiplying by r again. So if you think about it, right, to get to our second term to our fifth term, we have to multiply this -6 by our common ratio 3 times, right? So what it's saying, we're going to come up with a little formula here, crunch this down. -6 times r raised to the third power, right? That's how many r's we had to multiply here, is equal to -1296. And once we have it written like that, divide by -6. R cubed is equal to 216. Take the cube root, or raise them to the 1/3 power, and r is equal to 6. So basically 6 times 6 times 6 is 216. And now we just need to find our first term. So because we're multiplying by 6 to get all the way out there, right? 6, 6. All right. To go back to our first term, I have to divide by 6. So -6 divided by 6 is a -1. Okay. And so we have everything we need. A sub n is equal to our first term times our common ratio, n-1. And then we're looking for our 14th term. So I'm just going to plug this right into my calculator. 14 minus 1. So technically it's -1 times 6 raised to the 13th power. And you're getting -1.31 times 10 raised to the 10th power. In this case, your calculator would look like this. E to the 10th, which basically means that guy right there. Okay? Which makes sense, right? It's going to be a really negative large number, right? So, let's take a look at number 5. All right, number 5 looks a little different because, as you can see, we don't really have any numbers here, right? We got nothing but variables here, right? So let's just sort of take this piece by piece here. Okay, so they're giving us our first term and they're giving us our common difference, right? So what's happening is we're subtracting by a 1x each time. All right, so what they're saying here is if this is 3x, subtract x, this is 2x. Subtract x, this is 1x. Subtract x, we're down to 0. Subtract x, -1x. Subtract 1x again. -1x plus -1x is -2x. Subtract x again. -3x. Okay? So that technically would be our 7th term, right? This is first term, second term, third term, fourth term, fifth term, sixth term, and 7th term. Okay? So we're not going to do it that way, right? But as you can see, right, our 7th term should be a -3x. So let's see if that's how it plays out. Okay? So remember the formula for an arithmetic sequence looks like this, right? And so we know what some of those pieces are. 3x minus x. Okay, seems like we got a lot of n's and x's there, but that's all right. And then because I'm always speculative, I'm going to make sure that this formula works. So anywhere I see an n, I'm going to plug in a 1. 1 minus 1 is 0. 0 times negative x is 0. And then 3x minus 0 is just 3x. So I am satisfied. So this formula works. So now we have to do now is substitute a 7 in there. So we're going to get 3x minus x raised to the, 7 minus 1, which is going to be 6. So we're getting 3x minus 6x, which is equal to a negative 3x. Okay, last two problems here. 6 and 7. All right, so letter 6, or number 6, I mean. Looking for how many terms are in the sequence, or what term number 64 is. So in order to do that, I need to come up with the formula for the sequence, right? So negative 20 plus, and it looks like we're going up by 3, right? Yes, sir. Okay. So, plug this into your calculator, and you would find out negative 20 plus 3 times x minus 1. You have to replace the n with an x. As you can see, put it into your y equals, right? First term's negative 20, negative 17, negative 14. So you want to keep scrolling all the way down until we reach 64. Which in this case, 64. So 27, we're at 58. 28, we're at 61. 29, we're at 64. 29 terms, okay? Or maybe you're one of those people that needs to be shown the algebraic method, okay? So this is sort of like our a to the nth term, right? We don't know what term number this is, but we do know that when I substitute this in for a to the n, the only thing I am missing is my n value, right? And so you could solve this out, and you would end up getting n is equal to 29. Okay, so a couple ways you could go about solving that. But may I suggest the calculator method? Okay, it gets you there every time. All right, the important part is plugging these things into the formula correctly and being able to come up with that formula. So make sure you know how to utilize your calculator for these guys. All right, smarter, not harder. Okay, so the last one. Okay, this one we are multiplying by 4 each time. Okay, so that's what's happening here. This is geometric, and we're multiplying by 4. So, here's our first term, times 4 raised to the n minus 1. Plug this into my y equals, right? So this is going to be y is equal to 1/16, 4 raised to the x minus 1. All right, so you plug that in there. And lo and behold, right, our first term, 1/16, second term, 0.25, third term, 1, and so we're scrolling all the way down till we see 1024. So at 6, you're at 64. At 7, you're at 256. And at 8, you're at 1024. So this is 8 terms. Okay? All right. So anyway, I'll put up an answer key for the homework problems. Okay, so I only want you to do the odd problems. All right, and so good luck with those.